So question number, I'm not quite sure. So this g of x, which is this quartic, has x-intercepts at 2, 1, -1, -2. So obviously it will look something like this. State the definite integral represents the combined areas. So we've got 3 combined areas, this one, and this one. So if I have a little look and see what it looks like, and if I open up my graphing window, get rid of the previous stuff, drag and drop, I can see it there. So I'm going to have the area will be, I could write 3 definite integrals, -2 to -1 of g of x dx, but that's below the x-axis, so I've got to put a negative, plus the integral from -1 to 1 of g of x, but that's above, so I don't need to put a negative, plus the integral of the negative from +1 to +2 of g of x dx. You could switch the terminals. You could double up the first and the last. Now, there's a cute little thing I noticed on my calculator when I was doing this. If I go integral and I do root, if I select the first one, then I jump over and select the last one, it did it all, combined it, and gave you the answer of 8 units squared. It's a bit nice. Now if I consider h of x and minus g of x, so I've got h of x, and if I drag and drop, beautiful, and if I've got minus h of x, and I drag and drop, I can see that I've now got 3 regions, but this region down here, and this region up here, and this region here was combined 8. This area above is the same as that area down there. That's the same as that. So my exact area should be 16 now. And the definite integral will be, the definite integral from -2 to -1, top curve is h of x minus g of x dx, and I'm going to say that that's 2 of them, plus the integral from -1 to 1, where my top curve is g of x, and I'm minusing h of x because that's now my bottom curve, dx. And if I was to confirm that, analysis g-solve integral of the intersection, select the first one, xe, jump over to the last one, xe, shaded it all in and gave you an area of 16. Consider the function this, k is g with some sort of translation up or down. Study value is the d where there is no bound region between k of x and the inverse, or the negative of. Okay, so I want to look and see where the lowest point that the red curve is at. So I'm wanting to find what is the y value of the turning point of this lowest section. So I might go edit clear all, and I will just take this expression here, and I'm interested in g-solve the f-min, and the f-min is -2.25. So my original goes down to -2.25, or -9 on 4. If I was to move that up 9 on 4, so if I get rid of that negative, and I do plus 9 divided by 4, and I drag and drop that, it won't have any, it will have trapped area, because if I have negative of all of that, it will touch there and touch there, will be a trapped area. So it's got to be bigger than negative 9.4. So D has to be bigger than 9 on 4. So for example, 10 on 4 would be okay. Because if you look at the green one and you do the negative of all of that, it will then go down here and there'll be no trapped region. So